this video we start looking at quadratic functions, which are always of the form ax squared plus bx plus c. We're going to want to get it into this other form, however, because that will be how we will easily identify the vertex, which is located at h, k. Notice that in the formula we have an x minus h, but that h has changed signs, so to speak, when it comes to the x-coordinate of the vertex, but the k has stayed the same sign. We want to learn what each of these different numbers will do to our curve. Since this leading coefficient is negative, or since a is less than 0, that tells us it opens downward. Had this value of a been positive, then the parabola would have been opening upward instead. When a parabola opens downward, it has a maximum value. When it opens upward, it has a minimum value at its vertex. Identify the vertex. Well, this will be located at -2, +4. We change the sign of the 2 when it comes over here to the vertex from within the parentheses, but we keep the sign of the 4 the same as it is. To find the x-intercepts, we want to set y equal to 0. This is consistent with working with lines. We will have 0 equals negative quantity of x plus 2 squared plus 4, and I will choose to move that square to the left-hand side. This will give us x plus 2 quantity squared equals 4. Now I will square root each side of this equation, and don't forget the plus or minus sign on the right side of the equation. We will have x plus 2 is equal to plus or minus 2. Subtracting 2 on each side gives us 2 plus or minus 2. And if we add the two 2's together, we get 4. And if we subtract them, 2 minus 2 gives us 0. So our x-intercepts are 4, 0 and 0, 0. To determine the y-intercepts, we will set x equal to 0. Now we will do this from the original equation. We will have y equals negative 0 plus 2 squared plus 4. This will become negative 2 squared is 4, so we have negative 4 plus 4, which is 0, and that tells us that our y-intercept is at the origin, 0, 0. To sketch this function, we will begin by plotting our vertex up at -2, 4. We will plot our two x-intercepts at -4, 0, and 0, 0, and this should be enough information to help us sketch the curve. You will notice that our curve passes through two key points here, and that should be something you should recognize. Your standard parabola normally goes over 1, up 1, and over 2, up 4. This goes over 1, down 1 in each direction, and over 2, down 4. So these should be 5 recognizable points on this curve. Now let's identify the axis of symmetry. The axis of symmetry is the line which we can draw through the vertex of the parabola, which gives us a mirror image on each side. And if we remember that this vertex is our point h, k, the h value will always be part of our axis of symmetry. We will have the vertical line x is equal to h, which in our case will be x is equal to -2. Now, since this parabola opens downward, it has a maximum value, and that maximum value will be at y equals k, which in this case will be at the y value of 4. To determine the domain of this function, we look at where the graph extends left to right, and we can see that it continues forever left and right. For the range, we notice that it goes down forever, but its maximum value is at 4. This gives us the values we need for identifying the domain and range. The domain will be all real numbers from negative infinity to positive infinity, and the range will be from negative infinity to 4, and we include that 4 on the right-hand endpoint.